We are live, guys. Looks like we have 2 users, so let's hold off a few here.
Srinivas, you wanna turn on your camera? It's up to you. Okay, cool.
All right, it is 2, but we have some audience joining in, so let's hold off just a couple more here and give them a chance. Okay, guys, we are live. Go for it.
Okay, cool. Hey, hello everyone, and it's great to be here and work with McKenna to host this webinar. The subject today is how to manufacture device to scale for supply chain risk management and operational resilience. I'm David Liu. I'm leading strategic alliance in Industrial IoT Group in North America. In Advantech, my pleasure to introduce the presenter, Mr. Srinivas Kumar, Chief Product Officer and CTO in McKenna. Here is the agenda for today's webinar. First of all, we will quickly brief Advantech IoT strategy and alliance with our great valuable partners, which actually is one of the key factors that Advantech and McKenna work together. For example, on the second topic, we're going to talk about how to manufacture devices at scale for supply chain risk management and operational resilience. You are very welcome to put your questions in the chat room, and we will reserve some time in the end of this webinar. So in the past 25 years with Advantech, I've been witnessing the success of Advantech as well as the edge intelligence that has been transforming this company to another level. Here, I want to quickly share a strategy Advantech has been developing and offering to scale industrial IoT business with our amazing partner and customer around the globe. Advantech was founded in 1983. In the past 35 years, Advantech built up the global presence in 16 countries and 92 cities to provide industrial technology, product solution, logistics, and support in industrial IoT edge intelligence to ensure the success of our valuable partners and customers. In North America, we have around 500 people, and there are 2 logistics centers. One is in Milpitas, Northern California. Another one is in Ottawa, Illinois. We also have a branch office in Cincinnati, Ohio, urban office, California, and Eastern Canada. And we have a great local presence to provide the immediate support from business, technical, and logistics perspectives. To support our valuable partners and customers, Advantech is devoted to focusing on the 4 go-to-market sectors: general automations, factory, industrial equipment manufacturing, and industrial infrastructure, including oil and gas, new energy, environmental monitoring, transportation, and so forth. So here I to structure the reliable and the repeatable intelligent edge solution, especially from the the topic we're going to talk about today. We cannot miss any of the key layers, including the edge sensing, industrial communication, and edge computing. Edge sensing devices take care of both green and brownfields. Various edge devices protocol to connect the unconnected. Both wired and wireless solutions here facilitate the decentralized remote and outdoor IoT application through LoRaWAN, LPWAN, NB-IoT, LTE-M, Wi-Fi 4G, even 5G going forward with IoT protocols such as MQTT, concentrate application protocol, live end-to-end, and so forth. Industrial communication layer is to structure the reliable and secure machine-to-machine network, including industrial network switches, protocol gateways, data gateways, devices, servers, routers, and so forth. They are capable of transmitting critical and sensitive information. They are also purpose-built edge computing for various industries, such as compute for oil and gas, come up with the C1D2 and ATAX anti-explosion features. Compute for electrical energy, designed for the IEC 61850 standard. Compute for railway, vehicle, and other mission critical must be designed to meet their specifications, industrial regulation in terms of electrical and environmental requirements. This capability makes Advantech stand out, become the #1 industrial computer manufacturer for many years, and make a huge differentiation from others. So to complete a successful IoT project with edge intelligence, I must talk about the strategy that Advantech work with the alliance partner. Here, example, we work with Mokena. The strategy that Advantech to work with the partners is to focus on edge intelligence. So the Advantech has many software such as the many solutions, protocol. So we provide the compute platforms and connectivity, sensing control, and some middleware as a very important pillar to support our partner as we come together, work together as a platform. So our potential customer partner from A side, from channel, from ISP perspective, can actually quickly and easily carry their technology to realize the revenue. So the strategy advantage to work with our partner is always focused on edge intelligence. Okay, so Advantech has the many software solution, but in the meantime, Advantech is also proactively work with our partner to provide the edge bundle solution. So working with Mokena to validate the Mokena trust point software onto the Advantech edge devices in order to provide a secure industrial network is a great example. Therefore, our available partners and customer can receive the reliable, repeatable, and intelligent gateway solution, edge solution, to accelerate their business and services. Advantech is also looking forward to supporting our partner to co-create end-to-end services with which will drive the innovation and new growth further. So many IoT projects eventually go to the dead end is just because of lacking the past effectively evaluate the risk and quickly respond to a result. Sometimes people is too aggressive to jump to the end-to-end solutions without systematically aggregating and orchestrating the building blocks in each critical stage. But sometimes people are too conservative to move out the first steps, and they're missing some great opportunity. By providing the 3 steps actually with Advantech edge intelligence, Advantech and the alliance partner, particularly for especially with Mokena, can always work hand in hand to enjoy the success of business. Advantech is proactively developing the alliance partner eco network. All the partners can fully enjoy the eco partner activity with Advantech. In the meantime, Advantech and the partner continually seek for opportunity based upon the business and solution fit and come up with the edge solution bundle focused on the technological creation or partners' existing solution running on the Advantech edge intelligence devices. This is a sweet spot, as I mentioned, right? As the how Advantech and the partner can go further to take go-to-market actions once the edge solutions bundle is fully go through the markets, test and showing the potential. Advantech and partner may plan the edge enterprise services which can create a new business model and drive the new growth engine. So the following actually Mr. Srinivas Kumar is going to talk about the technology from Mokena. Actually, it's a great example that how Advantech and Mokena work together. So let's welcome Srinivas, the CTO in Mokena, to talk about the technology. Srinivas?
Thanks, David. So we start at looking at what the passage to digital transformation is in terms of what are the 4 fundamental things that need to happen. The industrial IoT subsystem in general, the ecosystem is a very horizontal platform. And so this requires a collaborative effort between the various players, starting from the equipment manufacturers to the device vendors and the service providers to make it cost effective. It also entails a OT-IT convergence mindset, because you're dealing with CISOs who come from an IT mindset. And then there's also a integration of emerging and emerged technologies in this space as we go on to various types of devices. There's the economics of it, there's the politics of it, there's the intellectual what's in it with this new technology, and the commercial story. So broadly, we look at this ecosystem as starting with a manufacturer, whether it's an OEM or an ODM, who could be pre-installing the technology that goes on the device, what we call as trust point. And this will also entail activating a root of trust on that device. From there on, the flow goes to the device vendor, who would have some additional capabilities if they want to node lock the device for licensing purposes. And then the devices could sit on shelf for weeks, months before it goes out to an end user. And the end user basically is the owner operator, who might either choose to install Trust Center as a service or go through a service provider. So that's basically what it entails in terms of a digital transformation mindset. And we look at 7 habits of a device that makes the device trustworthy. Starting with number 1, persistence of trust. This is basically the capability natively on the device to establish and preserve trustworthiness of the device throughout its life cycle. And also to ensure the data that is harvested and processed by AI, ML engines for analytics are trustworthy, safe, and secure for the mission-critical decision logic and outcomes, because this data, whether it's data to lake, data to policy, or data to process, is consequential in the OT side of things. Number 2 is reducing the lifetime costs. This is the means by which you reduce your CapEx, OpEx for both OEMs and the end user, and also scale and automate from manufacturing, deployment, for continuous monitoring of heterogeneous connected and edge devices. Because there's no 2 devices in the OT world look alike, and there's a lot of variation. Number 3 is how to manage the supply chain risk. This is the controls by which you can manage the supply chain risk for tamper resistance of content that is to be delivered, and the ability to track and trace the supply route from the developer onwards through providers, distributors, resellers, publishers to the target device. And number 4 is how to recover a device if it gets into an untrusted state. In the OT world, a device recall or sending a technician to the field is not pragmatic. So the ease with which operators can remotely orchestrate field device recovery to mitigate a service outage, roll back images or configuration to a trusted baseline, and also to rotate cryptographic artifacts that minimize exposure to published vulnerabilities and potential exploits. And number 4 is how to protect data that is in the custody of the device, the methods that would be utilized to protect data, whether it's at rest, in process, or in transit, for mission-critical applications that are either native or containerized. And then the ability to use a secure element as the root of trust. And then number 6 is how do you protect the digital assets? Because in terms of theft of intellectual property, when you're sending mission-critical data to certain operations, whether it's industrial, avionics, defense, you want to make sure the data is going to trusted devices. So ensuring that untrusted device is not getting a binary that can be reverse engineered and you lose your intellectual property. And number 7, last but not the least, is how do you achieve compliance? How does the device comply with all the IEC, NIST, NERC, FIPS, FCG requirements in terms of the certifications that are emerging for vendor interoperability? So these are the 7 habits of the trusted devices. Then we look at 5 degrees of protection. And what this means is a device requires 5 degrees from device identification and device authentication to establish trust, to key and data protection, and then finally to the operational trustworthiness to measure runtime integrity. Now, how you achieve each of these can vary. So when you look at device identification, whether you're going to use a root of trust that's hardware, firmware, or software-based, 0 passwords, or you use fingerprints. When it comes to authentication, what is good enough in terms of mutual authentication whether you want to use a shared secret or keys inserts, and how do you make sure that there's non-repudiation of the device identity. Then in terms of key protection, again, there are various means to have key stores in order to get workload isolation and be able to rotate the keys, renew the keys, manage the keys remotely, unattended in a headless device. And then in terms of data protection, it is a data privacy at rest. A stolen device can have data compromised. So how do you protect the data on the device and while it is communicating between devices? And also prevent cloning of devices, so you can node lock it so that the device cannot be cloned. And how do you maintain the supply chain integrity of data that originates from the device that goes into very critical analytics? And so it's important to have the integrity of the data. And then in terms of operational trustworthiness, how do you verify the boot sequence has not been manipulated? You can attest to the platform. And how do you monitor the indicators of risk at runtime so that your AI ML engines can provide valuable outcomes? So these are the 5 degrees, and to various extent, certain devices may have all the protections, and certain class of devices may not be able to provide all the degrees of protection. So protection is not absolute. It is really on the scale of 0 to 100. How would you qualify the degree of protection? So that then takes us to what does it look in terms of resilience? There are 3 rings of resilience, what we call as trust, protect, and measure. The foundational platform for trust at the core is what provides the APIs required for privacy and confidentiality. You cannot build trust on top of an untrusted platform. So when you start with the foundational element, do you have a solid core that can provide trust in terms of APIs? Because everything in software is based on APIs. Then the second ring of resilience is the protection that can preserve the integrity of content all the way from the manufacturer to the field upgrades, across the full stack, from boot loaders, boot images, OS configuration, application images, and so on. Because on these devices, the content is going to constantly change. From the time it leaves the factory, it might be sitting on shelf for 6 months. By the time it's installed, the firmware is out of date. So change is the only constant here. And finally, the measurements for the AI ML engines, which is the ultimate ring of resilience, because you want visibility before you can control. So how do you do the analytics in a timely manner? So that's basically, we started 7 habits, and there are 5 degrees of protection, and there are 3 rings of resilience. And then that leads us to the Mukana solution of a protected device. That is a solution that's designed to provide both processor and OS agnostic operations on a device, analytics, and the development platform based on the above concepts. So what you see fundamentally here in the is that there are clients that are installed, the Mukana Trust Point clients on the devices. These are all plug-and-play binaries that require 0 coding, that operate on wired, wireless, as well as air-gapped devices. So it is a horizontal platform in a very diverse deployment ecosystem. And it provides the core capabilities for device and data protection to harvest device intelligence so that you can do risk analysis. Because a lot of these devices are resource constrained, and you cannot really do risk assessments on a device that is under analysis. So you have to send that information out to the Trust Center services, which is an extension of the operations platform, where Trust Center provides a single pane of glass for OT security because of the remote visibility and control it provides through trusted device intelligence and measurements. Trust Center can be hosted on-prem or in any cloud. It includes connectors to a certificate authority of your choice, and it eliminates the cost and complexity of the PKI infrastructure. All the communication between the Mukana Trust Point clients and the Trust Center services are on a message bus architecture for event-based condition monitoring. And it's a very scalable message bus architecture. So that's the operations platform that is all plug and play. And then there is a development platform that is for line of business applications to provide built-in protection countermeasures, where the applications can leverage the same APIs offered by Mukana Trust Core that is leveraged by our own clients. It includes a very simple set of APIs for key and certificate management, for data protection, for use of secure transport protocols, in a way that the keys are fully protected by any underlying secure element of choice. It can be a TPM, it can be a SIM, it can be a MCU, and so on, including memory enclaves. So what you essentially have with the TrustPoint client is selective plugins for multi-factor verified boot, for secure onboarding with a immutable identity of the device. There are built-in embedded network access controls, so you can data diode the device in an industrial control network with a Purdue module, for example, using encryption with automated key management, key rotation. And you don't have to re-engineer any of the line of business applications, whether it's a brownfield or greenfield device. And you have a trusted content delivery from supply chain provenance. So those are the benefits that TrustPoint gives as a plug-and-play solution, where you don't have to do any heavy lifting. And then the Trust Center services provide the complete certificate and key lifecycle management and connectors to commercial and enterprise CAs. And they're integrated into the provider and publisher workflows for tamper resistance, and also provide RESTful APIs for AI/ML engines and orchestration engines. So that's basically the complete buy versus build, where you can literally buy this solution on a variety of devices. TrustCore as a development platform is again an OS and processor agnostic developer kit that provides a trust abstraction platform, which provides extensibility to any root of trust, whether it's a TPM, SIEM, Intel, APID, SDO. And it also provides a crypto abstraction platform that allows you to plug in a crypto engine of choice, whether you want a US-based crypto certification, or there are US export restrictions or import restrictions in Europe and China. It does not, it is very agnostic to the application, and we allow you to plug in any solution of choice in terms of cryptography. So what it means now for the OT-IT convergence is, while the IT mindset has been traffic inspection based on intrusion detection and anomaly behavior detection, there are challenges because of the transparency that the messaging has today on a unencrypted wire is also a liability. A transparency without protection with unencrypted command and control messages in a safety critical ecosystem poses a risk. So with the emerging standards for data integrity and confidentiality with NIST 853 and so on, with IEC 62443, critical systems will have to migrate to a more encrypted posture. And the plurality of the application protocols makes it very difficult to start creating a baseline for intelligence sharing in the OT industrial silos. Because a lot of the threat information that is available inside of let's say a nuclear grid or a utility plant, those utilities will not publish it for public scrutiny. And so where TrustPoint and Trust Center come in is providing safety nets that harden the devices to remotely recover the devices if there's a compromise, as well as coexist in an OT-IT ecosystem. TrustCore is a very modular stack, which is basically at the guts of the core of our solution, which is OS and processor agnostic. And as you see, it's a very layered architecture. We work very closely with various silicon vendors and secure element vendors and operating systems, and we provide the abstraction layer. And this abstraction layer with trust abstraction and crypto abstraction allows us to plug in through our security module plugin architecture any secure element of choice, which gives a lot of flexibility, especially on Intel, Xilinx, ARM-based architectures, where we see that various devices have various types of foundational elements. We also provide a software-based cryptography, which is a FIPS certified 140-2 level 1 certified stack today, and we're also in the process of supporting 140-3 for US consumption where FIPS is required. And the security protocol stacks that we provide, which is pretty much the whole slew of protocols from TLS to IPsec, they all leverage our abstraction platform and secure key protection. So the applications, whether it's a C, C#, C++, Java, Python app, is totally unaware of what's below. So we literally give you that platform that application developers can leverage without getting into too much of the detail. So what the solution architecture now rolls up is we have the field connected devices that are either connected peer-to-peer or device to gateway or device to cloud. So in this ecosystem, you can put TrustPoint on various kinds of devices in smart city, smart building, smart factory kind of applications. And then you subscribe to a Trust Center service that is hosted in any cloud by any service provider of your choice. And all this just magically happens. You see the analytics, you see device intelligence, you know the device is protected, you can remotely configure the device, send updates to it with supply chain integrity. And at the same time, we open up our APIs to third-party data science partners who do the AI/ML engines. So you have an auditor of sorts who can continuously monitor what is really happening on the device without the application developers having to write syslogs and have to look at application level protection provided, which is just impossible because of the volume of applications out there. And so now when you start looking at use cases, what is the use case for connected devices? When you look at connected devices, the field, edge gateways, the 5G MECs, and the endpoints, they require authenticated enrollment. That's really the onboarding. They need tamper-resistant content delivery for data, for images. They need embedded data dioding to make sure that they're not fully exposed at the edge without a very expensive DMZ and firewall. And they need event logs for risk monitoring. And then when you look at lifecycle services that Trust Center can offer, these connected devices need key and certificate management. They need a trusted supply chain that's integrated into a workflow in a way that updates can be provided all the way from the developer to provider to publisher, a data historian for analytics, and also support for multi-tenancy so that there's multi-site, multi-tenant orchestration. And this is where we see the value of trusted data going into the analytics engines. And the connected devices are very much a 5G MEC edge control, edge cloud market, because the low latency and the purpose-built containerized applications that will go on these gateways for various types of applications, whether it's a smart city and so on, require the trustworthiness of data. When we look at a second use case of production systems, now the production systems obviously are different in that you have HMI workstations, controllers, sensors, actuators, and so on. But they do require a identical protection profile as the connected devices. However, the requirements for managed services is different. It is focused more on authentication methods, key rotation, without the complexity of PKI infrastructure build out, because these production systems don't really have the ability to retrofit API infrastructure. And in terms of where you would use it, this is industrial control systems, smart grids, where 24/7 uninterrupted operations is required without service outage. And the challenge for modernization in these ecosystem is budgetary constraints, heterogeneous brownfield, greenfield devices. And so it takes a phased approach in order to get the device vendors to participate in a way that is interoperability. So that's basically a use case of how we go into production systems, where we provide the device interoperability across the vendors. And then a third use case would be mission systems. And these are the extreme where you require a nation-state attack protection, you require protected boot sequence, command and control integrity, because a tampered message can have serious consequences. And they also operate on resource-constrained platforms. When you look at aviation, space systems, these are systems where memory and processing is not infinite. The requirements for managed services are identical to connected devices, but because of the risk posed by nation-state actors, there's a lot more of supply chain risk management. And so that's another flavor of a use. And then there's a device protection use case where you're looking very atomically into the device. And with trust score and trust point across various form factors, we can provide the protection like immutable identity, authentication methods, key exchange, the data signing, verification, encryption, and so on, to various types of devices. And this can be accomplished with either zero coding or minimal coding of line of business applications. And obviously, the types of risk you encounter on different devices is different depending on the class, function, and resource constraints. A smart bulb is not concerned about a nation-state attack, but a jet engine is. So we have solutions for various stacks, from a very high-end enterprise Linux with all the memory and processing, where you can go down to a less resources device, which might have an RTOS with a lightweight stack, and all the way down to a microkernel architecture. And you can literally go down to something that has very limited resources and still be able to provide the same benefits, but with different levels of key strengths and protocols. But at the end of the day, you can still harden the device to a point it's better than where it is today. And when we look at a typical 5G cloud scenario, the Mokana Trust Core and Trust Point is integrated with various secure elements from various silicon vendors and device vendors we work with. So on scale, because of the heterogeneous devices, what Trust Core provides is lightweight controls for authentication and messaging integrity between endpoint devices. And you can also, on devices which require minimum memory and storage trust point protection can be extended. We have machine-to-machine use cases, device-to-cloud use cases, and with partnerships that we are having with various device vendors, we are able to put these on Linux, Windows, RTOS platforms like VxWorks and FreeRTOS and so on. And so that basically gives a complete coverage, a ubiquity of sorts on various devices. You can also install the trust point protection on a gateway, which you don't have to go all the way to the device. And a lot of the smart factory, smart building use cases would actually start off with an edge gateway into a 5G MEC cloud. And we can put trust point on the 5G MEC cloud itself, which would be a very containerized, hardened platform through an SD-WAN interface down to the service provider in the cloud. And we have integrated our solution with several service providers and also on various cloud platforms like Azure, AWS, and so on. Now, we are not taking sides on any cloud platform or service provider. We provide this as a technology, and it's multi-vendor. When you look at smart building and smart workplace, the types of devices we look at is cameras, motion sensors, HVAC equipment, lighting controllers, air quality monitors, and so on. So these are the types of devices we have historically been on, like networking equipment, wireless access points, and so on. And these are typically managed by a MSSP for the buildings and enterprise IT for workspace. So we have the workflows. So whether you're an MSSP or an enterprise IT, how do you provide that single pane of glass based on who is the owner and who is the operator of these devices? When we look at smart factory, different types of devices. You have industrial robots, controllers, pumps, meters, cameras, and these are operated typically by MSSPs. So that's where we would work with MSSPs to bring the service to the end customer. A smart city, again, a whole different type of devices, right? You have traffic lights, parking meters, street cameras, you got water management systems, public transportation systems. And we are able to be on a lot of these types of devices. And in this case, it's typically operated by the city, by the IT of the city, or by MSSP, or it could even be a telco who might want to take on this role in the smart city. So again, it works into our workflow where we can work with a service provider or with end IT, managed IT.
Okay, thank you, Srinivas. This is great technology, from Mokena, and Advanta actually is looking forward to, has been working with Mokena hand in hand to, such as the Mokena Trust Core Trust Point is being validated on the Advanta Edge gateway for different kind of applications. And also the trust server actually can also put on the Advanta server as well. So together with Advanta, as mentioned, right, the three critical areas in terms of edge sensing, in terms of connectivity, in terms of compute, then Advanta can work with Mokena hand in hand to provide really good device protection and great cyber security for your applications. So once again, right, Advanta actually provide those great products and as an important pillar to support our customers and our partners. So we can create the platforms as a carrier to carry our partner customers' technology to realize their IoT vision and scope. Okay, so I think we are kind of run really fast, and we have some time, and Adam will help us to facilitate some of the questions you might have. Adam?
Yes, there are some audience questions here, so I'm going to copy and paste these that were sent over. I'm going to paste these into the chat so we can all see them. I just posted question number 1 for you two, and there are 3 of them total. So if you guys want to take that first question, I'll
Okay, sure. Do you wanna to brief what the questions?
Yeah. This is Srinivas. So I can take the first one. The question is, as the end user of IoT devices, where do I start with digital transformation of brownfield and greenfield devices? Fundamentally, the low-hanging fruit is to begin with the greenfield devices, which can be updated in field or at the time of manufacture by contract manufacturer. So this gives you the ability to quickly quick start this process for coexistence with legacy brownfield devices. So there would be a mix and match of greenfield, brownfield. And then the legacy RTOS-based devices will have to be upgraded through device vendor update cycles, which could be a 6-month to 12-month to 18-month window. So that is how it would be gradually phased in, starting with edge gateways, starting with greenfield devices inside of the fence, and then gradually into the RTOS-based devices, which are generally monolithic, and you cannot do an incremental update. So you have to work it through a release cycle of the device vendor. So that would be a smooth process to roll this technology into an existing infrastructure.
Great. And then I have question 2 here coming in from the audience. I'll paste that one now here.
So as a CISO, should I budget for device hardening and risk management? What are the capital and operational expenses that I should plan for? Device hardening requires planning to coordinate the updates through device vendors and line of business application developers, right, as part of the update cycle. So from a planning perspective, whether it's a development budget, that would be put into the next release cycle is something you would plan for. That would probably be a one-time NRE kind of an expense for you, not a recurring expense. A lot of times with some of our trust point solutions, there is no line of business application development required. So that reduces your in-house costs. Risk management requires trust center services. So for trust center, you need a hosting platform, whether it's on-prem or in the cloud. So depending on what kind of server farm infrastructure you have in-house, or who the cloud player is, whether it's AWS or Azure or Google or whoever, you'll have to plan your infrastructure in terms of CapEx. You might already have the equipment, in which case Trust Center Services is a Dockerized payload. So you're just installing literally Docker containers into your VMs. So in terms of hardware, you may not even require a lot of additional CapEx, but there is obviously some element of using the hardware for the VMs. And then from the operational aspects of Trust Center, when you look at the initial ramp up of install and configuration, this is probably a few man weeks of work to get everything into the system. And the real cost reduction comes over the long term when you can do remote orchestration for the SOC to do security monitoring and recovery. So the upfront operational costs would be purely onboarding of devices, configuration of the system, which would be person weeks of effort and cost.
Okay. And then we have question number 3 here coming from the audience.
Should I manage the transformation program beginning at the device level through OEMs, or directly through device vendors, or at the service level through managed service providers? The digital transformation, like indicated in earlier slide, is really a multi-phase approach, requires collaboration with multiple parties. So in this multi-phase approach, depending on your target environment and compliance requirements, the quick start zero coding approach would obviously be the first phase, where you work with the equipment and device manufacturers to instrument the device platforms. That's where the OEMs and ODMs come in, because they can pre-install the trust point clients, for example. The next step, once you have the agents, is to work with a service provider or in-house IT to set up subscription-based services for those instrumented devices. So that would be the second phase. And that would bring a lot of devices under the OT umbrella of a single pane of glass. And then there would be other devices. The final step would be to coordinate with the device vendors, whether it's a VxWorks platform or a QNX platform and so on, to see how they could install the trust point clients in the next release cycle. And send those devices can onboard. So it'll be a staged onboarding of various class of devices. So you end up at the end of the day with a unified approach, a single pane of glass.
Okay, great. Do we have any other questions?
Okay. Yeah, that's great. I mean, I think that's about today's webinar. I really appreciate this opportunity to co-host the webinar with McKenna, with Mr. Srinivas Kumar. And looking forward to working with our audience on air, customer and partners, and looking forward to work with you. And thank you so much for today. Thank you.
Thank you.